Imagine the scene after a disaster. A landscape of gray dust, shattered structures, and mountains of rubble. Hurricane Katrina left behind over 118 million cubic yards of debris. The 2011 Japan earthquake created 20 million tons of waste. Traditionally, all this material, these grim monuments to what was lost, are trucked to landfills at immense cost to both our wallets and our planet. But what if this rubble, this symbol of destruction, could become the foundation of a more resilient future? Today, we're exploring a revolution in reconstruction, building with the remnants of what was destroyed. It's a concept that's transforming disaster debris from a liability into a valuable local resource, creating stronger, more sustainable communities from the ground up. This isn't just about recycling. It's about a philosophy called resilient architecture. The goal isn't to simply rebuild what was there before, but to build back better. This means creating structures that can withstand and quickly recover from future shocks. At its heart, resilient design is about understanding a specific location's vulnerabilities. In an earthquake zone, you'd use flexible foundations that can absorb seismic energy. In hurricane-prone areas, you'd focus on aerodynamic designs and reinforce structures to resist high winds. For wildfire country, it's about using fire-resistant materials and creating defensible spaces around buildings. Several key principles make this possible. First is structural integrity. This means robust materials, like reinforced concrete with steel bars, and flexible systems that can sway to dissipate energy. Second are innovative materials. We now have ultra-high-performance concrete, fiber-reinforced polymers that can strengthen existing structures, and even engineered wood like cross-laminated timber, which is both sustainable and incredibly strong. Third is smart planning. It sounds simple, but avoiding construction in high-risk floodplains or on steep slopes is critical. 4. Flood zones. Elevating buildings on stilts is a key strategy. Finally, there's redundancy and sustainability. A resilient building might have a backup power generator or a secondary water source. It also uses passive design, like natural ventilation and shading, to reduce reliance on energy, making it more self-sufficient during a power outage. Green roofs and permeable pavements can also help manage stormwater, reducing flood risk. So how do you turn a pile of devastating rubble into a new building? It's a meticulous process. The first step is debris management. Teams on the ground sort the material into categories. The most valuable is construction and demolition, or C&D debris, concrete, bricks, wood, and steel. There's also vegetative debris like trees, which can be chipped for mulch, and white goods like appliances, which contain recyclable metals. A critical category is hazardous waste, asbestos, lead paint, and chemicals, which must be carefully separated and disposed of to ensure safety. Once sorted, the transformation begins. Concrete and masonry are crushed to create what's called recycled concrete aggregate, or RCA. This can be used in new concrete mixes, as a base for roads, or as fill material. Wood can be salvaged for framing or flooring, and steel can be melted down and recycled. The innovation here is remarkable. RCA is a game changer. Research shows it can replace a large portion of virgin aggregate in new concrete without losing strength, and using it can reduce carbon dioxide emissions by around 40%. In Amsterdam, a project called the Mobile Factory has developed a portable system that turns rubble into Lego-like building blocks. These blocks can be assembled without mortar, creating earthquake-resistant structures that can flex under stress. After wildfires, salvaged timber can be used to create engineered wood products. And then there's earthship construction, an innovative method that uses discarded tires packed with earth to create thick, insulating, and highly disaster-resistant walls. This isn't just theory, it's happening all over the world. After a devastating earthquake in Cianjur, Indonesia, a Recycle House program helped rebuild 352 homes. They used a mix of recycled materials from the wreckage, like repurposed wood and concrete shards, and locally sourced materials like coconut wood and bamboo. Crucially, the community was actively involved, which not only provided shelter, but also a sense of empowerment. In New Orleans, after Hurricane Katrina, community-led rebuilding took center stage. The Make It Right project, famously spearheaded by Brad Pitt, focused on building 150 affordable, green, and storm-resistant homes in the hard-hit Lower Ninth Ward, incorporating solar panels and rainwater harvesting systems. Perhaps the most dramatic example is Greensburg, Kansas. In 2007, a massive tornado wiped out nearly the entire town. Instead of just rebuilding, the community decided to reinvent itself as a model of sustainable living. They passed a resolution that all new public buildings had to meet the highest green building standards. Today, Greensburg has the highest concentration of LEED-certified buildings in the world. Wind turbines generate 100% of its electricity, and a sophisticated water conservation system is in place. It's a powerful story of rising from the ashes, stronger and more sustainable than ever. The benefits of this approach are enormous, and they fall into three main categories. Environmentally, it drastically reduces landfill waste and conserves natural resources. It also cuts carbon emissions. For example, making aluminum from recycled sources uses 95% less energy than making it from scratch. Economically, using recycled materials is cheaper than buying new ones, especially when you factor in the high cost of landfilling. One study found that using recycled materials in highway construction could result in life cycle cost savings of up to 23%. This process also creates jobs in collection, sorting, and manufacturing, giving a much-needed economic boost to disaster-stricken areas. But the social and psychological benefits are just as important. Involving residents in rebuilding their own homes fosters a sense of ownership and can be a deeply therapeutic process. It helps people regain a sense of control and channel their trauma into something positive. However, it's not without challenges. Technically, ensuring the quality and consistency of recycled materials can be difficult. Sorting and decontaminating debris is complex. Logistically, the sheer volume of debris can be overwhelming. And there are regulatory hurdles. Many building codes are outdated and don't include provisions for using recycled materials. In the U.S., FEMA reimbursement policies can sometimes make it easier to get paid for landfilling debris than for recycling it. Finally, there's public perception, a potential shortage of skilled labor, and the high initial cost of processing equipment. Despite these roadblocks, the path forward is clear. We need continued research into new technologies, updated building codes, financial incentives, and public education. Ultimately, building with disaster debris is part of a much larger idea, the transition to a circular economy. In a circular economy, waste isn't an endpoint. It's a resource that's continuously reused. The Build Back Circular framework, proposed after the 2023 earthquakes in Turkey, offers a roadmap for this, focusing on upcycling waste and involving local communities. By embracing these principles of resilience and circularity, we can transform how we rebuild after disasters. We can create a future that is not only more sustainable and equitable, but also more hopeful. The rubble of today can and must become the foundation of a better tomorrow.